Today we'll prove an interesting trigonometric identity involving inverse sine. Specifically, we'll prove that 3 times the inverse sine of x equals the inverse sine of 3x minus 4x cubed for x between -1/2 and +1/2. The key to proving this identity is to use the triple angle formula for sine. The triple angle formula states that the sine of 3 theta equals 3 times sine theta minus 4 times sine cubed of theta. Let's approach this step by step. Step 1. We'll let theta equal the inverse sine of x. This means that sine of theta equals x. Step 2. Let's substitute this into our triple angle formula. Wherever we see sine theta, we'll replace it with x. Step 3. Now, we'll take the inverse sine of both sides. On the left side, we have sine of 3 theta, so taking the inverse sine gives us 3 theta. On the right side, we get the inverse sine of 3x minus 4x cubed. Step 4. Remember that theta equals inverse sine of x. So 3 theta equals 3 times inverse sine of x. Therefore, we've proven that 3 times inverse sine of x equals inverse sine of 3x minus 4x cubed. Now let's discuss why this identity only works for x between -1/2 and +1/2. The domain restriction ensures that the expression 3x minus 4x cubed stays between -1 and +1, which is necessary for the inverse sine function to be defined. And that completes our proof. We've shown that 3 times inverse sine of x equals inverse sine of 3x minus 4x cubed for x between -1/2 and +1/2, using the triple angle formula for sine and careful manipulation of inverse trigonometric functions.